So let's look at what JUPEB chemistry questions. So if you are doing a JUPEB program in Nigeria, then and you are going to write chemistry, you want to look at this type of question here because you are going to see this kind of question in the exam. It's under what general chemistry. It's under what general what chemistry. So you want to pay close attention here. So I will use this question here to explain so many things for you that you possibly see in your examination. This is a typical theory question. If you're familiar with your question, you know that they do set kind of question in the exam. So now, what makes you a good student is your ability to analyze and know how to tackle the question. The question looks so complicated, but I'm going to explain to you. You have to cover what balance of chemical reaction. You have to look at what reactant masses. You have to look at how to write chemical equation. So there are three things you have to look at in this class based on this question here. So let's get into it. So first of all, let's analyze the question here. This is that 4.0 gram of sodium chloride is heated with manganese 4 oxide in excess concentrated tetrasulfuric acid H2SO4. The chlorine gas liberated is then passed through potassium iodide solution to liberate iodine gas. Can you see that? So it is said that HCl gas was involved and is being passed through potassium iodide. So now they gave us what mass of sodium chloride. So now let's look at what the question. Look at what, because here we have A, B, C, D. We have A, B, C, D, right? So the first they say what balance the equation for the reaction. So this is what is the reaction. So you have to what balance chemical equation. So you can use a special method or your guide method. So I believe you can use a special method. If you know how to use a special method, you should be able to what balance what this equation. It should not be an issue to you. I will explain that. B, they say calculate the mass of magnesium oxide used. Magnesium 4 oxide used. So here you are calculating what the mass of magnesium 4 oxide used in the reaction. So what is the mass of magnesium oxide that react with 2.40 gram of what sodium chloride to produce this, and this? Do you understand? Now C, provide an equation for the production of potassium chloride for the reaction of chlorine and from the reaction of chlorine and which chlorine gas and potassium iodide. Now here you want they say she want to write the reaction between chlorine gas and potassium iodide to produce potassium chloride. You see how technical the question is. Then B, D, which is the last one, calculate the mass of iodine liberated. So you have to calculate what the mass of iodine liberated. So as we move on, I'm going to show you step by step on how to do that. So, but therefore, let's balance the chemical equation first. Let's balance what the chemical equation. So you are going to write everything out. Take out NaCl, right? NaCl plus H2XO4 plus MnO2. Then you have NaXO4 plus Na2XO4 plus H2O plus Cl2. So how do we balance the equation? Remember, here we have sodium, chlorine, hydrogen, sulfur, oxygen, manganese. The same thing we have here. So we have to balance. We have to balance sodium, chlorine, hydrogen, sulfur, oxygen, and manganese. So how do we do that here? Now, how many sodium do we have here? Yeah, how many sodium do we have here? Here we have 1 sodium. So in the reactant side, here we have 1 sodium, right? On the product side, how many sodium do we have here? Here we have 2 sodium. So 2 sodium. So for me to make here to be the same here, I have to put 2 here. So if I put here, so here we have come with 2. So it's balanced, right? Hydrogen. If you look at hydrogen, here we have H2. Here we have H2. No, let's look at what chlorine first. Chlorine. Here we have how many chlorine do we have here? Here we have 2 chlorine. 2. Then here we have how many chlorine here? Here we have 2 chlorine. So it's balanced here. Hydrogen. H2, right? H2 here. How many do you have here? Here we have 2. How many do you have here? Here we have what? 2. So it is what? Balance. It is what? Balance, right? Sulfur. How many sulfur do you have here? Here we have 1 sulfur. Here we have two sulfur, 1 here, 1 here. Do you see that? So yeah, because here we have 1. Here we have 1, making what? 2. Sulfur is not correct. Sulfur is not complete. So how do I make sulfur to be complete? You understand? If I should put 2 at this point here, sulfur is not complete. Do you understand? But understand that if 2 is here, how many hydrogen do we have here? Here we have 4. Remember, yes, 2 already, right? So you have to put 2 here. So that hydrogen will become 4, 4. 4, 4. This is that. So sodium is 2. Sodium is 2, right? Correct. Chlorine is 2. Chlorine is 2, correct. Hydrogen is 4. Hydrogen is 4, correct. Sulfur is 2. Sulfur is 2. So here we have 2 here. Now look at what manganese. Manganese is 1. Manganese is 1. 1, 1. So look at oxygen. Let's check if oxygen is correct. Here we have, remember, here we have 2 times 4, 8 plus 2, 10. So on the reactant side, here we have 10 because 4 here, 2 here. 2 times 4, 2 times 4, 8 plus 2 here, which is 10. Then let's check here. 4, 4, and 2, 10. This is that. So they are all balanced. So the first thing to do here is say what you want balance the what chemical equation. You should want balance what the chemical equation. That's what you want to do. Balance what the chemical equation. So once you have balanced the chemical equation, then you are done with the first one. Now B, they say calculate what the mass of magnesium oxide used. So how do you calculate the mass of magnesium oxide used or magnesium 4 oxide used? You get now if you look at the question here, so we are talking about the B part now. If you look at the question here, they give us a mass of sodium chloride. So mass of NaCl is what? Is 4.0 gram. Now they are not asking you to calculate what mass of what? Magnesium 4 oxide. Do you understand? So in the sense that they gave me this guy here, they say she will calculate on here. So I'm going to bring out the 2 of them out. Please understand this here. I'm going to bring this one out. I'm going to bring this one out. Why? Because they gave us the mass of this one here, and they say she calculate this one here. So what I'm going to do, I'm going to bring it out. So it's going to be 2 NaCl. Then you have MnO2. Can you see that? So 2 mole of this equals what? 1 mole of this. This is that. Now I don't want to waste my time to be solving everything here. So I just looking at this guy and this guy. So from here now, I need to get the mole. I need to what? Get the mass. This is that. How many moles do you have here? We have 2 moles. How many moles do you have here? We have 1 mole. Can you see that? So how do I get the mass? I get the mass by calculating the molar mass of the compound. By calculating the molar mass of the compound. So how do I calculate molar mass of NaCl? So molar mass of NaCl. So if you not to calculate, if you not to calculate molar mass, you have it here. So it's going to be the atomic mass of sodium, which is what is 23 times 1 plus what? 35.5 times 1. Here we have 23 plus 35.5. You go to be what? 58.5 gram per mole. Do you understand? So what does it mean? It means that for every 1 mole of what? Of sodium chloride, I have what? 58.5 gram of what? NaCl. That is meaning. Do you understand? That is what the meaning. So in the sense that how many moles do you have here? You have 2 moles. So going to be, so the mass is going to be 2 times 58.5. We have 117 gram. So what about this one here? Magnesium 4 oxide. So molar mass of magnesium 4 oxide, molar mass of magnesium 4 oxide is what? Magnesium 4 oxide is what? Okay, manganese, not magnesium, manganese is going to be 55 times 1 plus what? 16 times 2, right? So 60 times 2, 87. So here you go to be what? 87, because here we have 1, right? So you're going to be 87. So now what I want to understand here is that in order for you to be able to get the mass of manganese here, so just put this together here, get a mole, get our their mass. That's what you want to do here. So I want to write some here. So to get the mass is very easy. The molar mass times this, you get this. The molar mass times this, you get this. So the molar mass of what? Sodium chloride is what? 58.5 times 2. That's how we got this one here. The molar mass of this one here is what? Is 87 times 1. That's how we got this one here. Do you understand? So the next thing you want to do here is this. What this means here is that what this means is that 117 gram of what? Of sodium chloride is equals to 87 gram of what? Magnesium 4 oxide. That is meaning. That is what that is meaning. So this way you are able to do your calculation. Remember, we have been asked to calculate the mass of manganese 4 oxide, right? So it means that because it's mass to mass relationship, mass and what and mass. That's why we say gram and gram. Mass of NaCl is equal to what? Mass of this one here. The mass of NaCl is what? Is 117 gram. While mass of this one here is what? 87 gram. Do you see that? So now I want to do the calculation here. So this is what you want to do here. So question mark mass of MnO2 is equal to now what is the mass of sodium chloride given to me is what? 4.0 gram of what? Of NaCl over what? 1 times. Now this way I'm not going to use on here. 117 gram of NaCl will go to the down, white one will go to the top, so that they can easily cancel that. So you have 87 gram of what? MnO2 over 117 gram of what? Of NaCl. You see that this will cancel out this one here. So what we want to 4.0 times 87 divided by 117. So here we have 4.0 times 87 divided by what? 117. You have 2.9. So mass. So you have to write here mass of magnesium 4 oxide is what? Is 3.0 gram.